Hi there. My name is Neil McIsaac, and I'm a Microsoft technical trainer. In this video, we'll be covering how to manage and evaluate models using the Azure Machine Learning service. Specifically, we'll look at how to register an MLflow model in Azure Machine Learning, and we'll also spend some time reviewing responsible AI and the responsible AI dashboard. So let's get started. If you recall earlier in this course, we can spend a lot of time developing models, and these models, and I mean the actual files for them, they can be spread all over the place. We also looked at MLflow and how it can help us log information about these models so that we can keep better track of them no matter where they're developed. At some point, though, we need to get those models over to production. More specifically, is that we need to have them deployed out into a real-time or batch endpoint. But how do we control the process of organizing which models are ready for deployment, especially if they're potentially spread all over the place? The way that we do this is by registering the model with the Azure Machine Learning service. When we register the model with the service, we end up creating an ML model file, which is going to contain the model's metadata. It allows us to use the model directly in things like pipelines or deployments. You can see in the slide here that an ML model file has been created, which we can see in the outputs and logs page. In this example, the model was logged using MLflow's auto log feature. It's possible to log the model manually as well, but in order to do that, we have to define the signature of the model. The signature is the definition of the inputs and outputs that the model will accept. In other words, what data needs to be passed to it to generate a prediction as input, and then what data would be returned from the model as the prediction. The ML model file format consists of metadata that describes our model. The file usually includes the artifact path, which is the location of where the model is logged to, the flavor, which describes which machine learning library was used to create the model, the model UUID, which is simply the unique identifier for the registered model, the run ID, which is the identifier of the job run that created the model, and lastly, the signature, which describes the inputs and outputs of the model. Again, the inputs being the schema of the data that needs to be passed into the model when we want to generate a prediction, and the outputs being the predictions that are being returned. Once we have an ML model file generated, the last step is to register the model with the Azure Machine Learning Workspace. And you can do this using the Studio, the Azure CLI, or Python SDK. What this will do is add it to the model registry, where it can be more easily found within the Azure Machine Learning Workspace, as well as allow it to be used directly from the registry. For example, it's very easy to deploy the model to an endpoint from the registry. Now, let's do a quick demo on how to log and register a model using MLflow. All right, so let's start things off with looking at a notebook here. Whoops, I keep doing that. Where we're going to do auto logging with MLflow. So the first part of this, just setting up some of our data again, where we're going to put the script files in the folder. And we'll start things off with this train model autolog py file, right? Now, the big difference here is we're going to simply just tell MLflow to autolog. And it's because we're using a logistic regression, and so we have an algorithm that supports this. We just turn it on. We don't really have to do anything else. We can if we want to, so we can specify things like log param and things like that. But because we're using autolog, this algorithm would automatically log everything for us. So this very first script that we create is just a standard training script that's going to do that. So let's submit this as a job. Again, I'm doing this quick because we've already looked at jobs for that. So this is the autolog py file. And let's get that running. There we go. So that looks pretty good. And of course, we have a link to our job if we want to look at it. But that's pretty good. Okay. So, there's a lot going on with auto logging, and kind of what we looked at the last one. Even though you turn on auto logging, you can still specify some extra information about logging with MLflow. So in this one, we're going to specify the flavor with auto logging. And same or similar idea is we have a script. It's still logistic regression. There's not too much here, but this one, notice there's a slight difference in this statement. We're using the scikit-learn, right? And then specifying autolog. So this is simply going to kind of force MLflow to say, oh, autolog, using this flavor. Everything else is actually the same in here, right? So any of the other log statements, right, so log param is in here. Any of these are really kind of the same, and there's not that big of a difference on the script. The big one is just when we do the auto log is we're specifying the flavor as part of that. So let's create that script, and let's come down and get this going as a command job. So this is the scikit-learn, and off it runs. So I have two jobs that have been submitted, and that looks pretty good. Okay, so another big part of doing the logging, and when we end up logging the model, which is kind of our target, is we need to think about the signature. So this next example is going to look at how to infer the signature, and this is really when we have data that has a schema and everything. Can we do that? So with this one, notice the MLflow is autolog, but we're saying log model is false. A little further down, infer signature. So we're going to say, hey, here is the signature that we want to use. There's the input. There's the prediction data. So the X-train is the input, right? That's our training data. And the idea here is that with the training data, we have the schema with it, and so we can say, well, this was what the data coming in should look like. On the backside, what should the model give us in return, right? So this is what is going to be the returned results, aka the predictions. And so again, we're just supplying the 2 bits of information here to say, here's the input, here's the output. And we have the schema for both, so let's go and define that signature. Last part is we're going to specify we want to log the model using this signature specifically. And again, we're doing it under the scikit-learn and everything. So the big difference in here is that we're not doing auto logging for the model. We've set it up with a signature. So let's get this pipe file created and submitted as well. All right, so we get a number of jobs. So this is just the train model infer py file running. And it looks pretty good. Now, we can take this a step further where we supply the definition of the signature. The big difference on this one is you're going to see our signature is going to be based on a schema that we actually spend some time to define. Now, this can give you very granular control over what that signature looks like. Right, so what types of data is coming in, the names of all these columns, all of that stuff. When we turn around deployment, it's going to be there. So we have that. We have an output schema as well, saying this is going to return a Boolean value, and we are going to create a model signature using the input, using the output. So we get a signature object. Now we have something that we can pass to the log model statement again. So where the infer signature does that for us, this one we're doing more manually. We're still ultimately getting a signature for it. So this just gave us more control. So let's run this one. So now we have our py file. We're getting some of the other command jobs coming in, completing, running and completing and whatnot. So some notifications there. All right, let's come down here and let's submit this as a job. So that's our model signature. We'll go and run that. And off it goes. Now, a big part of this, right, when we go and do all of our training and we want that model to get logged, we want to register the model so it shows up in the model's interface, right there in Azure Machine Learning. So all this is really going to do is say, hey, let's build a model. We're going to look at a return job. Let's grab from that job, right, the artifact for our model, right? So you see the path here all the way down to artifacts, paths model. We give it a name. The asset type is an MLflow model, right? So we do have a file for that. Get more stuff completed. And we are going to create or update that model to the models collection, basically, in here and have that show up. So we do need to have one that's run, and we did see some things that were completed. And that's why it's important that we're paying attention to that. So we see what job, right? This was the job that we were referring to, and the model from that is going to get deployed with that name. All right, so that isn't too bad. Let's go over to our jobs, and I do want to show actually just double check something here. Yeah, so this is I just wanted the name for that. So autolog.py. So this is the one that's completed, right? So that's the one that we submitted first. The other one, there's a bunch that are probably still running. So let's go look at this job specifically, right? And we're hoping we saw a lot of notifications come in that things were completing. So let's use this very first one that is completed. And if we look at the outputs and logs for this, right, we see that it did everything. It read the data, did the split, all of these pieces. And so we can look at all the output for it. But what we are most interested in is the model. And so we have a model folder here, and we see the ML model file. So let's take a look at that. The ML model file is really all the metadata that we want to have describing our file. So in this case, what the flavor is, right? We see scikit-learn. We can see things like, the pickle file, so right there. So in this case, the model was outputted as a pickle file. We have the signature for everything, right? And inputs and outputs for it. All of that is right there. So this is the auto log to go and generate that. Now, that becomes very useful because that ML model file makes it very easy to do things like registrations, and then once we register it, we can turn around and use it for deployments and everything much more easily. So let's come down to models, right? And we'll look to see, this is the one that I believe this is the one that we registered. And so we registered that model, this is on the list. So even though we have a bunch of models sitting in the file system, only one of them is listed here. The one that we created. We can deploy these real-time deployments. We'll talk about that in the next video. But this is going to really help us to manage like the list of models that we really care about, not just all of the models that we might be playing with. So I think these are the ones that we're going to be more focused on to probably get to production. So all right, with that, I think we're pretty good to jump back into some content. Right, now that we've talked about those models right there. So let's get back in there, and we'll talk about the next section for this. All right, let's go. It's easy to focus on the accuracy of a model and continually try and improve it. However, how do we know if our model is doing predictions in a safe, trustworthy, and ethical way? So in this part of the video, we'll be covering what responsible AI is, as well as how to use the responsible AI dashboard in the Azure Machine Learning workspace to help assess that. We here at Microsoft are very big on responsible AI, and we take it very seriously. It should be very important to all of us that the models that we develop and use are done so in a safe, trustworthy, and ethical way. That's actually a pretty broad statement, since that can mean many, many things. So let's look at some of the areas that we need to consider. First, it's important that any AI-based system treats everyone fairly and avoids affecting similarly situated groups of people in different ways. So for example, when AI systems provide guidance on medical treatment, loan applications, or employment, they should be making the same recommendations to everyone who has similar symptoms or financial circumstances, or for example, professional certifications. What we don't want to see is an AI model make decisions based on factors that are potentially irrelevant or even worse, harmful, such as age, gender, or ethnicity. This can be a very challenging area to determine whether or not a model is fair, as well as if particular features are influencing the model poorly. It might be really easy to simply eliminate features that might be deemed questionable out of the training data completely. However, if historical data was used in our model training, then some of the features might be introducing a bias without us realizing it. For example, if we were to train a model to help process loan applications, it might be obvious that data such as age or ethnicity should not be part of the training. However, if our trained data, which is really historical data that was biased with those features that we removed, such as granting loans to people over a particular age, even if we remove the age feature from our training data, we might actually be introducing the bias without realizing it, since our training data has already been affected by that bias. So a lot of the times, it might be better to keep features that would be considered inappropriate in model training simply to determine if a bias exists. We also want to consider reliability and safety. When we're evaluating a model with respect to reliability and safety, our goal is to understand if our model can respond safely to unexpected conditions and resist any harmful manipulation. However, that can be a very difficult task depending on the nature of the model that we're developing. Our focus here will tend to be to examine how failures occur within our model. So, for example, what the failure distribution is, and if any cohorts, which are subsets of the data, if they have a higher error rate than the overall benchmark. So privacy and security is another aspect of the model that we need to be concerned about. Since we're building this model based on data, is it possible for somebody to extract secure data, including private data, from the model? For a complete AI-based solution, this could mean everything from how the original data was collected and stored, to how it's used during training and testing the model, to controlling where the model is stored and who has access to it, or to limiting the potential for data to be extracted directly from the model. Of course, we also would like our AI solution to be as inclusive as possible. The overall challenge with this is that if our training data was collected from older systems, the training data may not have any inclusive data that we want. So this can be an ongoing challenge to build inclusive models. Across all of this, we would like our models to be transparent, which means that we have the visibility to understand how the decisions were made from the model. And we do this by focusing on interpretability and explanations. In the Azure Machine Learning Service, we can examine explanations a number of ways, as well as examine things like what-if scenarios. Lastly, it's important to remain accountable for how an AI solution performs. And this can include things like ensuring that an AI model prediction is not the final authority on critical decisions that may affect people's lives, or that we proactively monitor and assess an AI's performance over time, especially as we update our solution. Since all model training is based on data, we need to start with our data sets to evaluate if there are any issues with it. We can do that by performing data analysis on the data before we use it for training. This can include exploring the statistics of our data, including the distribution of the data across different cohorts and feature groups. Determining whether there are any issues with fairness, error analysis, or causality as a result of the dataset's distribution, or deciding if there are any areas that we need to collect more data to mitigate error, such as collecting data for underrepresented feature groups. Or maybe introducing noise into our data to help protect the underlying data from being extracted from the model. When we're evaluating our model for errors, we can use the error tree or error heat map views in our responsible AI dashboard, along with cohort filtering to see if there are any groups that have a higher error rate than others. Once we identify those areas, we can dive further into the data to try and understand why it's different. A big part of evaluating our model is to examine feature importance, which is part of creating an explanation for a model. Feature importance quantifies the relative importance of each feature in the test data set as a whole, and it can help us identify the importance that each feature has in how it influences that model. We can evaluate the feature importance at the aggregate level or at the individual level. The aggregate level allows us to see how important a feature is for the overall data set. The individual feature importance allows us to examine the importance of features for an individual prediction, which is useful if we want to dive into a particular prediction and understand the why behind it. So in the two examples on the slide, on the left-hand side, we can see the aggregate feature importance, and you can see that income is the biggest influence over the predictions for all of the test data. On the right-hand side, for an individual prediction, we can see that the loan amount had the biggest influence in producing the prediction. Since we're also trying to evaluate the fairness of our model, we can also see that age is the third largest influencer for our aggregate feature, which might be showing that it's an unfair bias. But on the right-hand side, for the individual feature importance, it has a much, much smaller impact. Of course, it takes time to really understand our data and any biases that it might have. So in the Responsible AI dashboard, we can filter our data for cohorts, which are simply subsets of the data. And we can also compare one cohort against another. That way, we can evaluate our model to see if there's a difference between different cohorts and their performance or their error rates. So for example, we might see that one cohort is getting a more favorable prediction than another cohort. Once we discover that, then the next step will be trying to determine why there is a difference. Using the Azure Machine Learning service, we can create a responsible AI dashboard to help us evaluate all of this. In order to create one, we need to create a pipeline that has the Responsible AI Insights dashboard constructor on it and include one of the tool components for RAI, right, Responsible AI. And then we need to make sure that we use the Gather RAI Insights dashboard to collect all those insights into one dashboard. So let's go over to the portal and look at how to create and use the Responsible AI dashboard. All right, so to get started with creating the Responsible AI dashboard, right? I've opened a notebook up here, and some of the other ones we're going to start with, creating our data assets. But this one's going to be a little bit different than a lot of the demonstrations that we've done before. So just double checking that we've connected to everything. I did just double check that previous to this, that we do have our data. So it's just the diabetes, CSV and everything. One little thing that I did do is did make sure that we wrote the data out as a table. So it's really important that when we're doing the RAI, the Responsible AI dashboard, that we're basing our data, so training data, test data, et cetera, on ML tables. So that code was just do that from those Parquet files that I just highlighted. So we're setting up the paths for everything where our training and test data is. And then we're going to go and get the data, right? So looking at making sure we have that ML table, right, for our training data and our test data. So both of those are there. So again, just referencing data on that one. Okay, so here's where the magic really happens for the Responsible AI dashboard, or RAI, as you'll hear me refer to it quite a bit. So we're going to get the client to our Azure ML registry, right? So this is just our workspace, basically, with the registry name. This is where we can pick up like the model that's registered, because we need to have a registered model to really work with the Responsible AI dashboard. So let's get a connection to it. So running that looks pretty good. So that works. All right, so, and this is going to help give us access to all those RAI components that's listed there. All right, oops, I keep double clicking those. So registering the model, we have a model that we need to register. Again, we need to use a registered model, so that's all this is. We saw this in the previous video, previous demo in this video. So there we go. That looks good. And now we're going to focus on the pipeline itself. So the first little bit, we want to, and remember the pipeline's building the dashboard. So we want to go and grab the model that we care about to build the dashboard for. So that all this code is really doing is going and getting the actual model ID, right, for that with the the Azure ML protocol in front of it. So Azure ML colon. All right, here's where the magic happens. We're using the registry. We're looking at these components from the RAI dashboard. We're going to go get the insight constructor, and this is the first thing that we need to do with the dashboard is get that constructor, and then from that, or really kind of adding to it, is we're going to add error analysis. We're going to add the explanations on that, and we're going to do the component's called insight gather. But we're going to use these to add data to the insight constructor, which is kind of our dashboard. So this is just really going and grabbing the components, right? Remember the pipelines and components we talked about earlier, grabbing those components from that, but it has to be from the registry. Okay, once we do that, we do want to make a pipeline job. So here we have a pipeline, and this is going to, we just have it marked in as a decision pipeline. We are going to go through and do the work, right? So we have the target column name, the training data, test data for this pipeline. The title for it, so the RAI, Responsible AI Dashboard for Diabetes, and we can supply our model input and everything. So a lot of bits. And I know I'm going through this a little bit fast. There's just a lot of detail for it. So here's where we add the error analysis. This is referring to the component earlier, right? The error analysis component that we retrieved. We have the component for explanations, and then combine everything together with our insights dashboard. There's our error analysis. There's explanations, and we end up creating a job. So remember that pipeline jobs are basically a series of components that are configured. We add them, create them, and then run that job. So for this one, we're going to get that going, and we do want to supply the input for this, the input for the training data and the test data. So again, these are ML tables, and refer to the diabetic data that it was further up in the notebook. And then I'm going to come down and actually do the job, right? So the job, so we have our pipeline job kind of defined. We're going to set a few things like the target column. So these are the parameters for it. And training and test data, we're going to, there's a little bit of like just downloading the dashboard. So we're just going to output it in a spot. That's kind of a little workaround. That's pretty common. So let's get running that. And so there's a little bit of an error there. Let's see what it, you know what? I forgot to run that. So it's just the previous cell that defined the data. All right. So we ran that to define it. We want to run the pipeline. So we have it with all the parameters. So this is just a function to submit the pipeline, right? So the jobs, create or update that pipeline job. Short version of it, it's fancier code for it than what we've seen in some of our other demos, but that's all it's doing is submitting that job, that pipeline job. All right, so that's off and running. And so this does take some time to go, but because it is a pipeline job, it is possible to go over and look at the GUI, right? So the user interface version of, let me close all this. All right, so here's the graphical interface for these pipelines. Let's see if I can clean this up a bit. I guess that's as narrow as it'll go. And so here we have all of the components, and in the middle is that dashboard constructor. All right, so the stuff across the top was the inputs, right? And things like the model. So there's constructor, there's the error analysis, there's the explanation jobs, and those will get added to the insights dashboard. And then of course we're producing the dashboard at the very end. Now this is a pipeline job, so similar to the jobs, we got to spin up the compute, we have to wait for this to go. So this will take some time to do that. So let's see how it's running here in a little bit, and we'll just happily wait. All right, let's just take a closer look at what's going on. So we see the dashboard constructor. I see the little stripes running. That's going to be a little bit for that to run. Since this video has been pre-recorded, we've sped up this section to save you a bit of time waiting for this to complete. Let's see a refresh how it's doing. Still going. There we go. All right, so the dashboard constructor, it's completed. What we should see now are the other two components to run after that. So the error analysis and the explanation, those two jobs to go and do those. All right, so those are running. And of course, we're gonna have to wait for those as well. All right, so the explanation is finished. All right, and the error analysis is now finished. All right, so let's move this down a little bit further. We still have to finish the dashboard. So let's grab this and just move it down. So you see the gathering the insights, and then finally the dashboard being created at the end. So we just have to wait for that to run. This part of the process can take some time, so let me hit my magic fast forward button to jump to the good stuff. All right, now we have everything done. So see that everything's completed. That looks pretty good. So the dashboard hopefully is produced from this. It really should be. Everything seemed to run successfully. So we can actually view the responsible AI dashboard right from here. So let's go look at it. And this little prompt, I'll talk about it here in a second. We have our responsible AI dashboard here, right? So we see things like, you know, the cohort configuration at the top. Because we did error analysis, we have a whole section for that. And you know, this is connected to a compute resource, and it's really, it can be connected. We want it to be running because it'll give us a lot more functionality for this one, right? And we'll see that as we kind of play around with this a little bit. We won't go through everything in here, but it's really just to give you an idea of what this responsible AI is really about. So we can see things like the error heat map. So if we move around here a little bit, if we hover over any of these, we can actually see, you know, the statistics around what's correct, what's incorrect. We can kind of drill into them if we want to. So that can be really useful to see if we have a subset of data that is, you know, a cohort, and we can filter for those cohorts as well. But we can see if we have a subset of data that's being treated unfairly, for example, because the error rate maybe is a little higher than normal. The heat map, now you notice the heat map, when I come down here a little bit, that everything's grayed out. So the features, I can't select the rows or anything. I can see the overall error rate and everything, but I really can't do anything with any of these. And the reason for that is because that's part of the additional functionality to connect to compute. So we'll circle back to this in a little bit. You know, the compute's running, but we do need to connect to it and get that extra functionality a little bit. So we'll come back to that heat map and see us playing around with it. Okay, let's see what else to show. There's a lot in here. So looking at the model overview, we can see things like, you know, the metrics. with the data set, any of the features, how that compares. So sample size, accuracy scores, false positive and negative. So just basically our performance of like the model in this case. We can play around with what we're looking at, right? So the different metrics to see that. We can see things like, the probability distribution, metrics, to see the visualizations for it. You can see a confusion matrix if you want to. And we can play around with the labels. There's a lot of filtering, again, with the cohorts. We can do that. A little further down, we can actually look at some of the details, right? So correct predictions and incorrect predictions. So we can start looking at, what data is actually producing like bad results, right? That the model is not predicting properly. Feature importances. So aggregate feature importance, right? We talked about that. As well as the individuals. So we can see that in this case, pregnancies happens to be the most impactful one, followed by age. So both of these, we can look at some statistics and play around with those a little bit in the start. A lot of these are all very interactive as well. And if we come up a little bit, we can look at the individual feature importance. And for this one, because we're talking about an individual one, we need to select one of the rows, right? So I'll take an incorrect prediction here, the very first one. And we can come down and look to see the importance of that. So it's still pregnancies, but you see some of these have shifted a little bit. They're not as important when it came to making the decision on that one row. So that's not too bad. Okay, now that everything's connected up at the top, right? So we have that compute instance connected. Now we can get a little more out of this. And so if we go over the heat map, you notice that we can use that compute to do some of this filtering, really. So let's take, how about let's take BMI, right? And when we select one, we can see the different groupings of BMI and what the error rate is on those for that. So you see there's one group that is hitting 50%. So we might want to drill into why there's an error rate that's so high in that section. But we can cross-reference this with another feature. So for this one, it's just a little hard to get to. There's age, it's a little further down. And what we get is the heat map as a matrix. So the age going horizontally, the BMI vertically, and you see down here you get like 62%, and we can look to see what BMI that is, like what range, as well as what age range that is, that we're getting a high level of error rates, right? So you can work with that to go through it. So there's there really is a lot that you can sit and play with the responsible AI. Let me show you cohorts. That's probably the other big thing that just to get you started with this. Now cohorts, again, this is a way of filtering. So let's do one. How about like say age, if I can spell it right. There we go. Age greater than 50. All right, let's do that. And what we're going to do is base this filter, because it's a subset of data, based on the data set. We'll say I want to select age, and we'll say greater than or equal to. Actually, it should be greater than, but whatever. That's close enough. 50. All right, you get the idea. As soon as we do that, and there's a save, but there's also a save and switch. When we save and switch, we'll actually apply this cohort, it really kind of behaves like a filter, to all of the analytics that are on this page now. So things like the heat map changes, we can see things like the age greater than 50 compared to the all data. So this can help us, isolate cohorts and start comparing it against the rest of the data or even other cohorts for this. Okay, so it won't go through everything. There's a lot into it. So responsible AI, it's really important that you really focus on it because after all, we really want to have good, fair models. Okay, so with that, let's come back over to some content and we'll wrap up this video. And that brings us to the end of this video. I hope you enjoyed our discussion on registering models with MLflow and the Azure Machine Learning Workspace, and how to work with the Responsible AI dashboard. I hope you'll join us for the last video of the course where we'll be covering how to deploy our models. Thanks for watching.